Let's get going again. As step 3, now that we've run our refinery study, let's go back and take a look at exploring those results and kind of think about some of the things we can do there. Again, we can kind of visualize each of the different cases. We can choose which variable we want to sort by in that design grid. Just kind of see whether we want an ascending or descending order by any of the specific variables. We can switch over to the design table if we'd like to see the values associated with each individual case, or adjust the appearance of that scatter plot. So let's just kind of take a look at how we can sort of make the most sense out of the results in a way that will make it the most informative to us. Okay, so right now the results are basically showing with the y-axis and the x-axis just showing me the input values. It's often more useful to actually think about sorting that a little bit differently. So if you think about, the output values as being the result, for example, if I want to think about the trade-off between, maybe the material cost and the energy cost, you can start to see that, well, that's actually looking a little more interesting right now. If I go through and kind of think about the size of those dots, I can actually, maybe make that, maybe the solar value. You can sort of see that as I have the higher material cost, I have more potential over here for, well, the energy cost. It's a bigger building, it has bigger energy cost, but at the same time it has more solar potential, so it's looking a little more interesting there. I could also go through and colorize those. Okay, so one extreme case out here is way out there. It looks like if I'm looking at basically, what will I sort by? That's the lowest material cost. Okay, that's going from the, I take that back. This is actually the highest material cost right there. So it looks like our roof is biased towards being very expensive. That just makes sense that with a lot of roof, we do have an awful lot of solar potential, but just given our cost function, we're sort of finding that that has a very high material cost. Let's kind of look at it a little bit differently. Let's look at it in terms of energy. So this is going from ascending order. So this shape right here actually has the lowest energy cost, okay, all the way up to this shape over here, which actually has the highest energy cost. Okay, and it gets to sort of an issue of the wall area versus the roof area and kind of trading off the difference between all those different kind of potential considerations. So as you go through and kind of look at these results, the key is to really think about what is the essential trade-off you're trying to make. And if you're trying to think about, the material cost versus the solar value, okay, you can kind of take a look at those. What do we want to do here as opposed to that and the material cost? Let's kind of size that down based on the energy. Okay. You can sort of see that, just different points along here give these sort of different values. What's sort of interesting about this one, let me kind of zoom on in there again. I think what we did was we had the material cost versus the energy cost. The way this metric is set up right now, there actually is a little bit of a kind of a minimum there. Let me kind of see if I can zero in on that. I can filter and basically say only show me the cases within that range. Let's take a look at those in terms of the specific cases right there. If you kind of look in specific at that, you'll actually sort of find that there's a case back here which has a slightly higher energy cost. Okay, and there's a case over here that has a slightly higher energy cost, but there's one right here in the middle, thereabouts, which actually has the best material cost, or the lowest energy cost relative to the materials. So you start to see that little trough within there. Now, all these curves are very, very sensitive to the whole notion of really how you set up the basic equations and how you set up the different parameters, the different constants that sort of guide these things. So, it's really all about just trying to figure out the behavior that's kind of giving you the right result, the desired result. But if we were going for this and I was looking for something that was going to give me that kind of lowest kind of point between the energy cost versus the material cost, it looks like a shape down in here is actually somewhat interesting. Let's kind of pop on out though and sort of say, okay, there's this whole other way. Like let's take a look at this. Oops. Let me sort them back over here. It's not popping there automatically. If we get into, I'll sort that by energy cost there. Okay, and that's, oops, down this way. Okay, at least from an energy cost standpoint, that is much less efficient as a shape. So, what you often find in these kind of trade-offs is the shapes that are more, kind of evenly distributed tend to give you, or almost more spherical, or kind of more centric. They tend to have better behaviors when you're just kind of thinking about the geometry. But again, this analysis is very crude and very simple, so take it for what it's worth. It's really more just an illustration of how you can kind of use the tool to try and kind of figure out these different behaviors. In the next example, we're going to explore this a little bit more substantively. We're going to take a look at, as opposed to just sort of saying there is some sort of an energy value for the roof or a solar value for the roof, how we could actually use the solar analysis node to do something very similar to what we've done in some of the prior examples.